Hi, everyone. My name is Kannan Muthukkaruppan. I'm a co-founder at YugabyteDB, and it's my pleasure to welcome you all to the next episode of our YugabyteDB Friday Tech Talks series. These are talks by engineers for engineers, and it is my pleasure to welcome today on the show Denis Magda, and he's here with a very interesting topic. So, Denis, over to you. It'd be great if you could introduce yourselves. I know you've been on this series before, but still, for those of you who may be joining us new, it'll be great if you can give a short intro and then jump right into the topic.
Yeah, it's been a while since the first time we met at the YugabyteDB Friday Tech Talks. But yeah, hello, Kannan, and hello, everyone. Thanks for joining this session, and happy Friday. Hope you will have a wonderful weekend ahead. My name is Denis, and I am the head of developer relations at YugabyteDB. So basically, my role is to make sure that developers and database administrators are successful with our wonderful product. So the topic for today is building geo-distributed applications, a blueprint, some basic steps and considerations you need to take. We are going to talk about YugabyteDB inevitably, but this talk is more high level. We are going to look at the geo-distributed applications from the top, from your application layer, from the load balancers down to the database. And then it's up to you to decide how exactly to deploy this in practice. Before we start with the details, let me define a geo-distributed application. If you Google for geo-distributed application, you will find that basically a geo-distributed application is an app that runs across multiple geographic locations for high availability, performance, and compliance. On this picture, you can see that there is some application that has instances running across the planet. But also a geo-distributed application is an application that can be executed within a single region of your cloud environment. For instance, here we have another app, and that app has 3 instances, and those instances are deployed across several availability zones. This application is also a geo-distributed application. Or your geo-distributed application can be deployed across your country where you have your primary user base. In this example, we created some app. In this app is deployed across the United States in several major regions. So, and then the question is, let's figure out like the why. Why would you create a geo-distributed application? I guess that many of you who join and watch us today, you already have a pretty good understanding because you use YugabyteDB or planning to use YugabyteDB, but nevertheless, let me share with you my context. Imagine that we decided to create some sample application. We decided probably to reinvent the wheel, and we created a Slack-like messenger. Many of us use Slack these days to communicate to our colleagues at work. And we have some probably killer feature in mind. We released the first version of this messenger, and right now this instance is running in some of the regions in the cloud. We have a database deployed as well. And we have the first users. One of those users is Mrs. Blue, a financial advisor from New York. She loves our application. And what happens several days or several weeks later, there is some incident, some natural disaster that is happening in that region of the country, and our instance and our database go down. And we as startup founders, we generally were surprised a little bit because we thought that, all right, we are deploying in a cloud environment. The cloud environment should be resilient, fault tolerant, etc., because it comes with abundant resources. But in fact, we did our research and we found out that cloud outages happen. And they happen all the times. Zones go down, hardware can fail, network can glitch, and those are minor issues. In fact, there are also major issues that happen every 50 days across one of the cloud providers. And those major issues can impact an entire region, which means that if your application is deployed just within a single region, and if that region becomes unavailable due to any reason, then your application is unavailable. Amazon actually does a brilliant job. They document all their major incidents so that their customers and their engineering team can learn and improve from those incidents. And based on their statistics, on average, it took them 4 hours plus to recover from a major incident. So keep this in mind. All right, and going back to our new Slack-like messenger idea, we learned this lesson, and when we deploy the next version of this application, right now the application instances were running across several regions, and whenever another incident happened in a different part of the country, this time our application tolerated this outage because the database was available and the application was available, and Mrs. Blue, among other users, were happily enjoying our app. Okay, so the first reason why you would want to build a geo-distributed application is when you want to tolerate various outages, and those outages can be zone level, region level, and geography level. Now let's discuss other reasons when you would want to build a geo-distributed application. Let's say that our Slack-like messenger is gaining some traction, and right now people from Europe and Asia noticed this app. We have Mr. Green, a scientist from Berlin, who also installed our messenger and started using it. And we have Mr. Red, a musician from Mumbai, India. So, and then imagine that we had a chance to talk to our users, and we asked them one question. What would you say about the application usage experience? Mrs. Blue, who lives in New York, she would say that, wow, it's lightning fast. I truly enjoyed this messenger. And for her, and this response is not surprising because she lives close to the deployment location of our application. Okay, she's nearby. For her, the latency between her mobile phone and our database and our application instance can be as low as 5 milliseconds or even lower. Mr. Green still will be positive, but not as positive as Mrs. Blue. He can say that, yeah, I truly like this application, but sometimes it's not responsive. Sometimes I pull up my phone and I'm trying to refresh a discussion thread, and it takes several seconds to get the latest messages from my colleagues. And again, for him, he experiences this slowness because his traffic needs to travel under the ocean, literally through the cables that are dug deep under the Atlantic Ocean before these requests reach our application instances in the United States. And Mr. Red will be furious. He would say that I do not understand what people like this application for. It's always slow. It's impossible to use it. And again, his usage experience is based on this physical latency, on the laws of physics, because his requests need to travel through the land and then under the ocean before they get to our application instances, right? And what we need to achieve when we want to use our geo-distributed application, we want to build the apps when application instances and data that is needed for our users is located close to them, so that everyone, regardless of their location, will say that, yes, I like this app, it's lightning fast. So that's the second reason when you would create a geo-distributed application, when you want to achieve low latency across distant locations and regardless of the user whereabouts. And the final reason is compliance. You know, right now our application is deployed in the United States, and we already are getting the first users in Europe and Asia. But we might be in troubles. Yeah, probably right now our primary focus is the United States market, and that's why we don't care about deploying application instances and database nodes in other countries. But if once we decide to expand officially to Europe or to India, we can be in trouble, because Mr. Green's data, personal data, transactions can be stored in the United States, and that will violate GDPR requirements. And the GDPR is probably the most well-known law that everyone gives an example about GDPR when it comes to data regulatory requirements. But also in India, the Reserve Bank of India put in order a law requiring you to store transactional information about completed transactions in India and not in a different country. For instance, if our Slack-like messenger wants to allow some payments or transfer money from one account to another, then the compute part can happen in the United States, but eventually all the information about completed transactions have to be stored in India. All right. So eventually what you want to do, you not only want to deploy application instances close to your users, but also you want to make data residing in specific countries where your users are based off. To summarize, when you want to build geo-distributed applications, why would you want to build geo-distributed applications? First, high availability, when you want to tolerate various outages. Second, low latency, regardless of the user location. And third, you want to be compliant with regulatory requirements. Okay, so those are whys. And now let's get to the main building blocks to the main architecture. When you create a geo-distributed application, like that geo-distributed application will come with the same components that you have with a regular application. A regular application is the application that is executed within a single data center or a single, let's say, availability zone or single server machine. But with a distributed app, all those components have to be distributed by nature. For instance, if you have a load balancer, that load balancer has to be global so that users from all over the place can access this load balancer easily. Your application layer also needs to be distributed, meaning that you need to have several application instances deployed across several locations. If you're using Kubernetes and you use containerized applications, then you need to have several Kubernetes clusters that are deployed in several regions. And database, it's inevitable when you're deploying a geo-distributed application, you need to have a distributed database, and you know what database to use in this case. Now let's take a sample example, because I will walk you through the basic steps, and then we also will do a demo, because every YugabyteDB Friday Tech Talk doesn't go without a demo. I will be using Google Cloud, but this architecture that we're going to discuss applies to any cloud environment or your private environment. So we are talking about this Slack-like messenger. So we created a sample messaging application that can function across several locations. And right now, this by default, let's say if you want this instance, you have this app, right? And this app is deployed in some region right now in some availability zone. You have three microservices. The main microservice is the messenger microservice. This microservice is responsible for the key functionality of your messenger, such as you create user accounts, you have different channels, you send messages between in the channels, etc. And this messenger microservice communicates to YugabyteDB, because YugabyteDB is the main transactional database. This is where all the accounts and messages and channels are stored. The second microservice is called attachments, and this microservice is responsible for loading different pictures. Let's say one user wants to share a picture, and that picture will be uploaded using this attachments microservice and stored in Google Cloud Storage. If you're using another cloud environment, you can use AWS S3 or whatever is better for you. And the Spring config server, think about it as some utility microservice. Both messenger and attachments, they go to the Spring config server to load configuration. The configuration includes details such as database connectivity options, different logging parameters, etc., etc. And this is, let's say, a picture and design of a single application instance. And right now, this application instance is comprised of three microservices, and everything is running within a single availability zone. But we want to make it geo-distributed. How do we make it? First, you need to select, let's say, if to take a multi-region example, then you can have region A, region B, and region C. In every region, you need to have a dedicated Kubernetes cluster. Every Kubernetes cluster will be running its own instances of those microservices. And then you would also have a YugabyteDB cluster spanning those regions, and you would also have Google Cloud Storage. Google Cloud Storage is also distributed by nature. Your users, your mobile applications, so your front-end web applications, they don't want to communicate to these Kubernetes clusters directly, because every microservice will have its own IP address. Those IP addresses will be private, or you can change them, you can deploy, redeploy. Instead, those users will be, those front-end applications of users will be connected to a multi-cluster ingress global load balancer, and that load balancer will decide which application instance in which region will be handling a user request. It will be decided based on the user location and whether an instance is available on a specific region or not. We will see it in practice. So now let's walk through the steps, right? Let's say you want to deploy this, you want to have a blueprint for geo-distributed application. And let's assume that we use Kubernetes. It's not a requirement. You can deploy on virtual machines, so you can deploy on bare metal. It's up to you. But we will take Kubernetes for reference because it's truly widespread and it truly fits really well a microservices architecture. So let's say, considering that we have Mrs. Blue, Mr. Green, and Mr. Red who live in different countries, we want to deploy separate Kubernetes clusters, right? After that, step number 2, you need to decide about your database deployment. And there is no any silver bullet solution. It's up to you to decide which deployment option to use. When we are talking about YugabyteDB, for multi-region deployments, you can select various options. For instance, if right now that's the beginning of your story, of your application, of your project, and your primary focus is, let's say, the United States or North American market, you still can deploy a multi-region cluster in the United States, and you can define a preferred region that will handle all the reads and writes by default. And this way you will achieve the lowest latency possible and high availability across the United States. But still, you will have a trade-off. Users who live in different countries, they will experience, high latencies, but that might be okay for you at the given moment in time. Also, if, for instance, you are already at the stage when you have a global user base and you want to boost both reads and writes, regardless of the user location, then one of the standard deployment options that is supported by many databases, you can run standalone clusters of YugabyteDB. But here is a trade-off, is that if you need to synchronize data between those clusters, then it's going to happen asynchronously. And if your application needs to pull data from various clusters, then it's a responsibility of your application layer to pull this data, to join this data, to merge this data, and then to return it back to your user, okay? And another deployment mode that is unique for YugabyteDB is a geo-partition cluster. And this configuration, you can have a single cluster that runs across distant geographies, and then you have a special geo-partitioning column that pins your data to specific cluster nodes in specific regions. The trade-off here is that you need to introduce this column, right? You need to add this column to your schema, and you need to define the values for this column. Anyway, this topic is not about these multi-region deployment options. You will get the slides, and we discussed already in details various multi-region deployment options and best practices in our past Friday Tech Talks. So just take the slides and then watch one of the previous conversations. Once you have your Kubernetes clusters ready, once you figured out your database deployment, now the time has come to deploy your application containers, your application instances. And it's not surprised that if you already have, let's say, you need to deploy application instances in all of the locations where you have your data and where you have your users in your Kubernetes clusters. It's easy step, right? And final step.
Dennis, maybe, so there was one comment or clarification coming in, so maybe I thought I'll share. So I think there was, in your reference application, you show, message data in YugabyteDB and attachments in Google Cloud Storage. So there was a comment that maybe Google Cloud Storage is not really global in the sense that one object is replicated to all regions. But at least based on what I am reading, GCS does provide the optionality whether the attachments or objects stored in GCS whether they are single region or multi-region. But anyway, I thought I'd just share that discussion.
Yeah, that's a good point. I cannot give you a 100% precise answer right now. When I was looking and using Google Cloud Storage, at least they guarantee extreme availability, meaning that they promise to survive various outages, including region level outages. Probably there needs to be some configuration option, depends on
at least based on a blog I'm reading, it is an option. So there's probably a slightly different cost also, but I think end users can choose whether they want their GCS storage to be single region or multi.
Yeah, like how this picture can confuse, let's say, those who watch us. You have here region A, B, and C, and if you deploy your application Kubernetes in those regions, you can deploy YugabyteDB in the same regions. It's like possible, you just define this configuration. In Google Cloud Storage, I don't remember about this configuration. So like, I don't remember seeing any configuration that says, all right, I want to have Google Cloud Storage in this region. No, that doesn't work this way. You just deploy Google Cloud Storage, and then it's just a black box for you. It's a responsibility of Google to make sure that when you access this cloud storage, it's going to be the fastest way for you, and also they will take care of their data redundancy and data availability. Probably that makes sense here, but that's a good point. All right, moving back, and step number 4, right? When you have the application instances, databases, and everything ready, Then configure multi-cluster ingress or load balancer. In Google Cloud, we have Anthos, and that comes with ingress and load balancer. It's a special service. It comes with a public IP address. You can assign a DNS name to this public IP address, and then you give this DNS name to your mobile application developers and front-end application developers, and that's it. After that, the application logic will be accessing this load balancer, and the load balancer will be forwarding traffic to some locations. And I will show you folks how it works. Any questions or any clarifications, Kannan, before we switch to the demo? Because that's it about the slides.
Yeah, like I was going to say one other comment. If you go back to some of the options you described stretching a single cluster across regions. You described the option to create actually, for example, even a 9-region cluster with using the row level geo-partitioning capability where some rows live in 9-region or 9-zone kind of cluster where some rows live in region A, some rows live in region B, and so on. So these are a good set of options. Maybe one that we don't cover in the talk, but it's worth mentioning, and that trades off some amount of consistency for lower latency, which is like if you go to the slide where you talk about a single cluster with preferred regions, maybe that is good. Yeah, like for example, by default in this architecture, the request will go to the leaders nodes, right? The nodes where to get strongly consistent answers. But it might be worth mentioning one other deployment option you have, which is to use follower reads, which is right. Like you want to talk a little bit about that, Denis?
Yeah, as for the follower reads, it's a good point. Let's say that you have Mrs. Blue probably lives close to this preferred region, and that's why her requests always go to this preferred region, etc. But you can have some other users. For instance, some users can be living in the West Coast in California, and if you can sacrifice, let's say, how it's called, if you can,
like some amount of staleness, like if you can sacrifice for the reads, if you're okay with doing slightly stale reads.
And slightly stale reads.
So in a healthy network, that will be in the order of 1 or 2 seconds, not even that. Yeah.
Yeah, so basically those users who live in the West Coast of the United States, they can query from this node. You will have some staleness, but even if you have some stale data, it still will be consistent. It's always consistent. It's about, not the latest update. So that's one of the options. Also, another option that you can have that probably when you decide to expand to these territories, your first move can be read replicas. You can deploy read replica here and there, and also you will be getting, the data synchronously from the primary cluster to here, and the guys can read the data from these replicas with some staleness factor.
And I think the reference to the other talk you had, like the QR codes that you shared for the previous talk, I would also probably just call that out once more, because in this talk we covered a lot about the end-to-end deployment architecture and what you need to pay attention to, not just at the database layer, but in terms of your thinking about the load balancer, containerizing your apps and deploying it in multi-region. Whereas this set of talks, it focus that you see, you're seeing the QR codes too, they focus a little bit more on at the database layer, best practices around data modeling. How do you pick leaders, zones? Should you do follower reads or not? Should you create duplicate indexes to trade off some amount of write performance, but in exchange you get better performance on reads, right? So there are a lot of tips and tricks in these talks as well that I would encourage our listeners to check out.
Absolutely do that. And today's talk just expand this collection, and today's talk focus is just to talk about the high level architecture, about load balancers and about your application instances and Kubernetes clusters. So now let's get to the demo. So as for the demo, we decided to create a simpler version. We don't want to deploy across several continents. We will just focus on the United States. We will deploy our application across several regions in the United States, and we will have a database running also across multiple region locations. So going to my terminal window. So what I've prepared, folks, here is I'm using Google Cloud. Let me increase the font size. Right. I already have 3 Kubernetes clusters running. The first cluster is in US Central, the second is in the US East, and the last one is in the US West. And it usually takes, let's say, several minutes for Google to provision those clusters. That's why they are ready. Presently, my kubectl tool is looking at the US East cluster, which means that all the commands that I'm going to execute right now, they will be querying the cluster that is running in the east coast of the country. So for instance, if I see, do I have any application instances running in that location? You'll see that no, nothing yet. We need to deploy it. So let's go ahead and deploy our first, our messenger microservices in the United States East. I'm using a special batch script, and for that I need to go to the project folder, cloud, and we're going to gcloud, gke. So we are deploying those application instances. We are starting the services for Kubernetes. So here is right now, let's check the deployments. All the deployments are already ready. That's the attachments microservice. As you remember that we have the messenger microservice, that's the main one, and the config server is basically used by these two. So now let me pull the logs from the messenger microservice. Yeah, you see that that instance is started and it's successfully connected to my database instance. Let's take a look at our database. So yeah, this one is, I think this is something related to Spring. Yeah, sometimes I see this silver. Yeah, it's harmless. So my database is running across multiple regions. Let me increase the font size. It's in US Central, East, and West. So in the same locations where I have my Kubernetes clusters. And US East is defined as a preferred region. And that's what I did. So next, let's do this. Let me split the screen. And now I want to connect to this application instance because the application instance is running. And for that, I'm going to use this service, messenger service, and I can access it by using this public IP address. Okay, that's my simplistic UI. Let's connect. Test now. Test at gmail.com. Password. Okay. Test at gmail.com and password. We are in. So we have workspaces. We have several channels for different companies. And for instance, let's go to this channel. Let's send some message. Hello. And here is to the left, you can see that all these requests are going to this application instance. And on average, it takes, let's say, 80 or 90 milliseconds for this request to complete because my application, I'm located in the United States East Coast. I'm connected to the instance running in the United East Coast. So the requests go to this database node in the East, but then the database node needs to replicate changes synchronously to the West and to the Central. And the latency between East and West in the United States is around 65 milliseconds on average, which means that it's a pretty good number. It's good for my application. From the user standpoint perspective, you can see that it's very responsive. It's like it happens instantaneously. And you remember we can upload pictures. If you decide to upload a picture, yeah, this is something that we have. Yeah, that's the picture, and the picture was uploaded to the Google Cloud Storage. This is what you can load from the logs. Now, the next step, I want to deploy this application instance in the US Central because probably I'm getting more users in that location of the country. Let's split the screen once again. And I will execute the same command that will start all the application instances, but in the US Central location. Not that fast. First, I need to move to the right folder. All right, starting. It's going to be quick. And now let's check the deployments. Oh, it's all ready.
And at this point, does this service become, the load balancer becomes aware that this service is now also available at a different location?
We will get to the global load balancer because this IP address, this load balancer, this is a load balancer that is dedicated for this application instance. That's not a global load balancer. It's just a Kubernetes load balancer that allows me to connect using some public IP endpoint to this instance, but that's not a global one.
Okay.
This one, this deployment option in US Central, I will show you, it will have a different IP address for its load balancer. So first, let's connect to the logs. I want to see the logs of this instance. Yeah, the instance is running, no any requests yet. And here is my kubectl tool is looking at the US Central. And if I want to connect to that application instance, kubectl get services. Let's see what the IP address, that's the IP address for this instance in the US Central. Let's copy it. Let's go here. You see that's the central location and that's the west. The IP addresses are different.
Got it. For now, you're just manually being the load balancer.
Yeah, I'm just showing, like, let's say, like, this is what you do without having a load balancer. For instance, that's another application instance. I'm connecting to this application instance. You can see that right now, you can see the logs files here.
Yeah.
Let's send a few messages. Hey, from Central. Nice. Okay, so basically the setup is ready, and you will see that the latency is higher. Why it's higher? Because I live in the United States. I'm connected to their application instance that is in the US Central. So that's the latency. My requests go there, but then that application instance in the Central sends requests to the database node in the United States East, because the United States East database node is the preferred one. That's why the high latency. But anyway, like from the user standpoint, it's still pretty responsive. It's not a big deal. And for this version of the application, that's totally fine.
Yeah.
Now, the funny part, let's talk about the global load balancer, because I want to have a single application, a single IP address, and I want the load balancer to forward my request to the nearest location of the application instance. For that, I have already deployed that load balancer, and right now it's called multi-cluster ingress. And I will execute this command, and I will find this virtual IP address. I need to find this virtual IP address. I need to switch to this multi-cluster ingress is deployed in US East. So that's why I need to switch to the US East location. And now give me this IP address. Yeah. So that's my global load balancer. Now let's open a connection through this global load balancer. Let's connect.
So if this global load balancer is intelligent enough, then depending upon where you are coming from, like, and I know you're based in the east side of United States.
Exactly. So right now, right now I'm connected through this IP address of the global load balancer, and the load balancer already connected to one of these application instances. I have to see logs here, because this is the instance from the east.
Yeah.
So let's connect. And here it is. Hey, load balancer. And so load balancer properly detected my location. I live in the east, and it forwards all my requests to this location in the United States East.
So you're back closer to 110 milliseconds, and
yeah, it's like it takes for the writes, it takes, let's say, around 100 milliseconds, because it synchronizes across the country, my messages. But when it needs to load like a channel with messages, it's read, it's fast. It's like, like probably dozen milliseconds.
Yeah.
So now we are talking about geo-distributed application, and let's emulate an outage. Let's quickly do that. Let's say that we experienced some issues in the United States East region, and what I will do, I will just terminate this instance of the messenger in that region, And my expectation is that the load balancer, the global one, will detect this outage and will start forwarding my request to the instance in the US Central, because I want my application to remain available. I know that YugabyteDB will withstand this outage because I'm deployed across multiple regions, but I want the higher level of the solution to also be able to be resilient. So,
and before you do the failure testing, then is one question somebody wanted to just confirm with you that is it the case that the load balancer, the global load balancer, detected the origin of your request and routed you to an appropriate instance in a nearby region?
Yes, correct.
This is correct.
Yeah. And I'm using the global load balancer of Google, and every other major cloud environment, they have a comparable service. It's easier. It's built, like, if you want to learn more, it depends. Like, cloud environments have a notion of points of presence. It's a special, let's say, think about the tunnels. Like, you have Google network, and that's a very fast network. And in various locations around the world, they have those points of presence. And there is a point of presence to the Google network from my location. It's nearby. And when I'm sending requests to the Google service, to this load balancer, then the nearest points of presence is somewhere nearby me. And this is how Google determines that my request is coming from the east, and then it forwards this request to the application instance in the east.
That makes a lot of sense, yeah.
Okay, so now let me confirm that I'm looking at the United States East, and let me just shut down this microservice. So what I want to do, kubectl delete deployments messenger key. You can see that the application is terminated, right? If you go to this, that was the direct connection to this application. It's no longer available. And let's see what's going to happen with the load balancer. That's the application instance from the east. It's up and running. And this is my load balancer. Let me try, I'll try to type something. And you see, while I was typing, the load balancer detected that, all right, my connection in the east is no longer available. And it connected me to the instance in the central. Let's check that that's the case. I have to see logs in this place in the US Central. There's gmail.com, password. Come on. I cannot type the simplest stuff. One more time. That's fine. Password. Okay, and now we are in the central. Done. And you can see that right now my requests are being forwarded to the central instance and everything is running. This is how you could withstand outage in the United States East region without any disruption to your application. And then certainly when you decide to get back to normal operations, the region is available and it's up and running. You just bring back your application instance. It happens in this way. Okay, so let's see. The application instance is running. Let me read the logs once again. Yeah, it's starting, it's connecting. And now a little bit probably later, but if I can keep, typing something in this load balancer, I'm connected through the load balancer. At some point, this load balancer will detect that the instance in the east is available again, and you will see this authentication screen, which means that the session needs to be renewed. Okay, this is what's happening. Okay, so it means that we are back to the United States East. You see? And right now our queries are executing much faster. It's like 78 milliseconds. So that's the whole flow. So enjoy building geo-distributed applications. What else can I say? And as for
wonderful, I know we are a little bit past time, but I really wanted to thank Denis for a wonderful talk and a great live demo. Those are never easy. There are a lot of moving parts here. You did it really well. I would like to encourage all of you to join us again next week. I believe Karthik and Bala will be talking about analyzing operational data in YugabyteDB using Azure Synapse. So very, very interesting talk, like basically how you can capture change streams from YugabyteDB and integrate with Azure Synapse Analytics. So join us then. Thank you all. See you next week. Denis, over to you also for final comments.
Yeah, thanks a lot. Thanks a lot, everyone, for joining in. Enjoy your weekend and keep learning and keep disrupting with YugabyteDB.
See you all. Thank you.